Okay, now I'm going to talk about the way the circuit works. First of all, I have to say that this part is just the PWM part. This is just a measure device, which is an oscilloscope, and this is a double pole, double throw switch, which is gonna be like an H bridge in this case, simplify the way of the circuit. This is a DC motor and NPN transistor to control the speed of the DC motor. As you can see, here the motor is spinning a certain velocity and a certain direction. With the resistor, I can increase or decrease the velocity of the motor. As you can see, the motor is almost stopped. You can see if I increase the resistor, decrease the resistor, if I make more clicks, I make higher the pulse, and the motor spins at higher velocity. And if I activate this switch, the motor spins in a different direction. Using the PWM modulation, which is a certain pulse, activate the transistor and it spins a certain velocity, the motor. This is the practice one. Now for the practice 2. The practice 2 is about a stepper motor. It will be better if we have one in real life, but now we just have protect. In this case, the servo motor has 4 coils. Each switch is for each coil. When I activate this one, follow this circle, yellow circle. When I activate this one, the motor rotates in that direction. When I activate the other one, the motor spins 90 degrees. It's 45 degrees per coil, per switch, should I say. Now, another 45 degrees, and that is 135. Now, deactivate that, this, and activate this, it is 180 degrees. Deactivate this, that is 225 degrees. Activate this, 270. Activate this, 350, and that is 360 or 0. A digital way to do this is using an Arduino, taking care of the position of the coils. As you can see here, this is the 4 coils of the motor. When I energize one, the direction of the shaft is in one coil. When I energize 2 coils, is between them. That is the 45 degrees. Then when I energize just one, it's again at 90. Then again 135, and so on. It rotates until it reaches the 360 degrees. This is the table. This is a table that tells us the way of the coils are turning on. Each coil in this case has a letter. This is for the step 1, step 2, 3, 4, 5 until 8. The number of steps are determined by the number of coils, and depending on if you have a full step or a half step. In this case, this is for half step. What half step has a very interesting fact is that it has more torque than a full step, but also it is more precise than a full step. Now let's explain the next circuit, which is the last one, that is for a servo motor. The servo motor is a motor that using a PWM pulse, and the rest is just a power supply. It could be 12, 5, 9 volts. Let's start on. Let's fire it up. As you can see, I also use pulse modulation. Pulse modulation is in everywhere. In this case, I'm controlling how long is the pulse to control the position of the motor, the angular position. In this case, the motor is set it up at 100, from 0 to 180. If we increase this, the motor spins. As you can see here, is from the right to the left, from the left to the right. And now let's locate it as the instruction says. The instruction says locate the motor at 0, 93, and in my case is 31. I made the last instruction from the left to the right, from the right to the left. Now let's locate it at 90. We just have to adjust the position, the value of the pulse. That is almost 90, 91. Now on my ID number, that is 31. And as you can see, 30.9, almost 31. And from 0. So, thank you for watching this video and have a wonderful day.